Hello, everybody, and welcome once again to the Databases for AI live stream. We've got an exciting show for you today. If you haven't done it before, you're going to learn how to build your very first GraphRAG powered agent, and you're going to learn a little bit more about why you would want to do that in the first place. But hey, everybody, my name is Trevor Spires. I'm a solutions architect here at AWS. Really, I'm happy to have you all here. If you're tuning in the chat, let us know where you're dialing in from. I'm coming at you live from the great state of Maine. It is cold. We've got some snow outside, but I'm nice and cozy in my office. And I'm joined today by the lovely Emily and Melissa. Why don't you all tell them who you are, and we can get this show on the road.
Yeah. Hi, everyone. Thanks so much for tuning in. My name is Emily Bayuk. I'm a security engineer at AWS. And just like Trevor is also kind of chilly but cozy in New York City. And we also are joined today with Melissa.
Yep. Hi, everyone. My name is Melissa. I am a Neptune specialist solutions architect here at AWS. So I focus solely on everything Neptune and graph related. And I'm based out of Seattle, which it's pretty mild right now. I think it's like 50 degrees. So I'll take it.
I'm jealous. Oh, Trevor, you're muted.
Fail early in the stream. Yes, I was going to talk about how cold it is in the greater Boston area. Be sure to let us know where you're coming in from. We'll throw it up on the screen and say hello to you today. I'm really excited for this one because I've seen now a lot of demos. We got some Jersey City, love it, of GraphRAG, and we've talked last week. If folks would like to see, I'll post the link in the chat to last week's episode in just a second. We talked about kind of why you would use GraphRAG in the first place. And I think we left in a good spot to tackle today's topic, which is how would you begin implementing and building that. So I want to hand it over to you, Melissa, to kind of talk through, kind of recap high level set with folks on why GraphRAG, and then we'll get to building.
Yep, absolutely. So
Melissa, sorry, I'm just going to cut you off before you get started. Do we want to drop the link to last week's episode in the chat before we get started with today?
100%. I'm dropping it in the chat right now on YouTube and Twitch. If you all want to check it out, just click that link.
Awesome. Sorry, Melissa. Go ahead.
Oh,
let's hear it.
You're great to hear. Yeah. So just to talk really quickly about GraphRAG, as Trevor and Emily mentioned, check out last week's episode where we talk more in depth about kind of the combination of putting graphs and vector search together to even make GraphRAG. But really, GraphRAG at a high level works in a very similar fashion to a standard RAG application. And I have a high level architecture up on the screen here to kind of outline what a general GraphRAG architecture would look like. And you can see that a lot of the components of this are very similar to what you would have with the standard vector RAG approach. So you've got your data sources, you're still doing some type of chunking, you're going to generate embeddings for them, load them into a vector store. And then when you have people asking questions, right, you still go through the process of retrieving relevant content and then providing that as context to the LLM. So really how GraphRAG differs from standard vector RAG is, of course, in addition to our vector store, which we are still utilizing for our GraphRAG flow, we also have a graph. And that graph is really key to helping us provide additional relevant information to answering a question where that relevant information is not necessarily similar, like semantically similar to the input question. So the graph is really the key in getting GraphRAG to work. And we're going to talk about today. Today's really focused on walking you through how you would go about building a GraphRAG application, as well as hooking that up to an agent. So your agent can be powered by that. But really just to hit on, again, what are the types of situations where GraphRAG would be beneficial? It's going to be situations generally where in order to retrieve all of the relevant context needed to answer a given question, you really need not just semantically similar information, but you also need dissimilar yet still relevant information. And the example that we always like to use to kind of hit home with this is our example corp situation, which we're going to be building out shortly. But it's really answering the question of what are the sales prospects for example corp in the UK? And maybe my corpus of documents looks something like this. So we've got some documents about Example Corp and the widgets product that they sell. We've got some news articles and press releases about this huge Christmas demand for these new widgets in the UK. We've got information about how Example Corp is planning on transporting all these widgets everywhere. And so naturally, the way to kind of answer this question with the standard vector RAG response is, well, we want to find semantically similar chunks to that input question. So we're probably going to pull out chunks talking about sales prospects, Example Corp, and the UK, which will yield kind of these top 3 chunks here, which pass those as context to an LM, and it's naturally going to infer that sales are really going to be great. Whereas you can actually see that on the bottom here, we actually still have some relevant information that we really need in order to come to a complete, fully contextual response. And these 2 chunks right here are not necessarily semantically similar to the input question, but you can kind of see how it's still relevant because it ties in to the entities that are mentioned in the semantically similar chunks. So
This is the part, by the way, that I'm maybe most intrigued to see today is kind of how it is on the back end we create these connections between things that, to your point, are connected, but at face value, especially if you're looking at semantic similarity, may not so obviously be connected. And we got, by the way, we got another Bostonian in the chat, Manish, saying, "Hey, this works great for CVEs and vulnerabilities and stuff too." If you want to learn more about this specific use case, by the way, we're having another show tomorrow on Friday where we're going to dig into a use case where you could actually use GraphRAG to help with security incident detection and response. So if folks want to dig more into that, join us tomorrow around the same time.
Yeah, right up my alley too. So, so Melissa, I really like this example. And for people just tuning in, could you give like a 1-sentence summary of why someone would want to use graph versus regular RAG?
Yes. So in situations where I think if you're asking more nuanced questions, where the answer to those questions would require context across multiple documents, multiple chunks, and like conceptually multiple different themes or topics of information, I think that is the situation where you'll find that GraphRAG is going to give you improvements in the responses as compared to vector RAG. And as an example, right, let's say if I'm just asking a question like, where are the widgets produced, right? Like that type of question, widgets are probably going to be produced in, XYZ location versus a question like, what are the sales prospects for this widget in the UK? Like there's a lot of different factors that, like if I was answering this as a human being, right? There's a lot of different factors I would need to consider in order to answer that question.
Gotcha. That makes sense. So like GraphRAG is more like understanding how things are connected.
Yeah, exactly. Yep.
Awesome.
GraphRAG is all about making it easier and even possible to extract relevant but dissimilar information that is still key and needed in order to answer the original question. So it's all about extracting like in these connected orange bits down here to answer the question.
Amazing.
Awesome.
Well,
should we build one or?
Yeah, I think so. I guess I'll pause and ask folks in the audience if you have any questions. Just conceptually about how GraphRAG works. One great thing about the show is it's live, so we'll keep an eye on the chat and we'll try to answer those throughout. But while we wait for those questions to come in, I believe so, Melissa. I believe it would be great to to get in and show folks how they can start building themselves.
Awesome. All right. So before we get started building, I'll just give a little bit of context behind the method that we're going to use today. So there's a couple ways to easily build GraphRAG applications. One is through what we call Bedrock Knowledge Base's GraphRAG. It's always kind of a mouthful to say, but essentially that is a managed way to build a GraphRAG application. And the nice thing about using Bedrock knowledge bases for building GraphRAG is that it's super easy. All you have to do is put all your source documents into S3, and then behind the scenes, it does all the processing for you to do like entity extraction, build the graph, do the chunking, generate your embeddings. It does everything for you and then puts it into Neptune Analytics, which I'll talk more about in a second, and then gives you a nice interface for querying. So that's going to be the easiest way to get started with GraphRAG. Today, I'm actually going to show you an alternative method to building GraphRAG, which is using our open source GraphRAG toolkit, which is on our GitHub, and we'll link it in the description. And actually, all the examples that we're going to be showing you today and the walkthrough is going to be posted in the description and in the chat. So you'll have access to everything we're talking about today. But the GraphRAG toolkit, what we really love about it is its flexibility, and it's very highly customizable. So in terms of supported vector stores and graph stores, it does support a number of different data stores. For example, for the graph aspect, we support Neptune Database, Neptune Analytics, and Neo4j. And then on the vector side, we support at the moment Neptune Analytics, OpenSearch, as well as Postgres with the PG vector extension. So a little bit more flexibility in terms of the actual data stores that you use, and super easy to get started with. And this is the method that I'll be showing today.
Awesome. Thanks, Melissa. And again, we're doing this live, so people who are tuning in, if you have any questions, definitely let us know in the chat and we'll do our best to answer as many as we can.
Awesome. All right. So before showing this, I'm just going to flip over really quickly to Neptune. So just for the ease of like keeping all my data in a single location, I'm actually going to be using Neptune Analytics as both the graph store and the vector store today for our GraphRAG application. But as mentioned, you can feel free to kind of mix and match the backend stores that you want for your graphs and vectors. Now, I've already pre-created my Neptune Analytics graph, and really what Neptune Analytics is, it is a memory-optimized graph database that can hold both graph data and vectors as well. So you can associate vectors directly with nodes. So for this, I have already created my graph here, and once it's up and running, all that it exposes to you is an endpoint, and then we just plug that in to our GraphRAG toolkit so it knows where to read and write the data to and from. All right, let me zoom in a little bit. All right, so I've already installed a lot of the dependencies that we need. So of course we need the GraphRAG toolkit. We also need some components from Llama Index. As we're walking through this, you'll see that we do reuse and pull things like readers and chunking strategies, and we reuse what Llama Index provides.
Melissa, what exactly is Llama Index?
Yeah, so Llama Index is a framework that provides a lot of helper tools and functions to make it easier to build generative AI applications.
Awesome. Thank you.
All right. So our first step here is I'm just going to set the vector store in our graph store to my Neptune Analytics graph, which I've already pre-created. I've already done this step, but we do provide sample source data for you all to run through this example. And we can actually check this out here. So I've just pulled it locally into my Jupyter notebook. And just for context, the interface that we're working with is what we call a Neptune notebook, which essentially it's just a hosted SageMaker Jupyter notebook that has our open source Graph Notebook library on top of it. And it just makes it easier when you're interacting with Neptune because there's a lot of one-liners, magic commands that make it easy to do things like query the graph. You can load it, clear it out, delete, reset all the data if you need to. Just makes it easier to work with Neptune. It is open source, so if you want to self-host your own Jupyter notebooks instead of using the SageMaker ones, you can absolutely do that as well.
Plus one on the notebooks. I would even go as far as to say, like, if you're not already a developer, I found that notebooks are a really interesting way to these Jupyter notebooks, an interesting way to get started because it is line by line and you can run each line of code once at a time and really kind of understand what's going on. So if you're not a developer by trade or you haven't experimented with it before, it's a really good opportunity to get started in a way that's not going to throw you into a 200 line script to get the process started.
Yeah, absolutely. Yeah, I love the notebooks. I use them for everything. Plus one for that. All right, so just taking a look at some of the documents that we are going to be using as our source today. You'll notice that they're all markdown files. So this is kind of simulating the different journal articles and like press releases and news blogs for the example corp example that we have been talking about, and the same content that we demoed in last week's episode as well. So a bunch of journal articles about our fictitious example corp company, and then of course some articles about the logistics company that it uses, how that logistics company is utilizing this new turquoise canal. So we've just got really a collection of unstructured text documents that are in markdown format here. And so I think depending on what you're trying to do, at least particularly for GraphRAG applications, your data sources are likely going to be mostly unstructured text documents or unstructured data of some sort, along with maybe some semi-structured information. Just because, we'll see in a second, but the underlying graph that we are going to be building, or technically the toolkit builds it for us, it's going to be in the form of what we call a lexical graph, which is essentially just a way of structuring different concepts and information within your source data based on how they relate to each other through things like shared entities, shared relationships, and just general shared themes and topics of what your data is talking about. All right, so flipping back to our example notebook. So we've already copied our sample source data locally. And now that we have our source data, it's really just a matter of calling the toolkit to go build the graph for us, as well as our vector index. And so you just need a few bits of code for this, and I'll talk through kind of what some of these are. So the first bit here is a configuration to specify how we are going to chunk our documents. And chunking is going to be a key part of how the GraphRAG toolkit is going to be able to kind of structure and build your graph. And so because we are providing a set of markdown files, it kind of logically makes sense to pick a chunking mechanism that is going to break down our chunks based off of the markdown headers. And so we're just reusing the markdown node parser from Llama Index, but again, you can swap it out with other parsers that Llama Index provides. Um,
Awesome. If you
yeah,
don't mind, we got a
yeah.
question that I think is interesting before we move forward too far. And actually, this was news to me, Melissa. I actually didn't realize that we supported GraphRAG in knowledge bases now. So I guess the question really is, like, what kind of knobs do we expose in the managed version, and do you have a sense for when you might use the managed knowledge base versus maybe a standalone custom configured GraphRAG database?
Yeah, so in terms of knobs that are exposed for the managed version, so through Bedrock knowledge bases, it will be a lot of controls over the chunking process. So how you want it to do the chunking. You can pick the embedding models. So there's definitely some toggles on the Bedrock side for how your documents are going to get processed. I would say that probably have more control over that in the toolkit, because as you can see here, we can choose the chunking ourselves, or if you wanted to, you could implement something custom. Same with the source documents here. So at the moment, the Bedrock knowledge bases does expect your sources to be in S3, versus here, right? We can just kind of plug in any of the Llama index readers. So you've got things from what I'm using here, which is just reading simply from a local file system. You can read from S3. You can scrape web pages off things. In terms of the design decisions for a lot of the extraction process, so like entity extraction and kind of shaping classification of entities, I would say that you do have a lot more control over that on the toolkit side. You can actually customize a list of entity classifications like product, sports team, company, so on and so
Very
forth.
nice.
You can actually like pass that in through the toolkit. And if you wanted, you could even customize some of the prompting that it uses versus with the with the Bedrock knowledge bases. A lot of that is kind of already fixed behind the scenes, so you don't have to think about it.
Makes sense. Yeah. Yeah. I know, the Bedrock managed versions, tend to be like a kind of golden path implementations, but a great way to get started quickly and learn if you're just trying to build your first GraphDB.
Yep, absolutely. And then just the last thing I'll mention is one of the differences as well is going to be the graph model, which I'll talk more about it in a second when we see like what was built. But the graph model, both Bedrock knowledge bases and the toolkit use a form of lexical graph. How granular it gets also differs a little bit. And subsequently, how each one does the actual retrieval of context is going to differ as a result of the differences in how they kind of model the lexical graph. So yeah, in summary, the toolkit is going to be great if you really want to kind of like tweak and kind of fine tune a lot of aspects of the entity extraction, creation of the graph, retrieval process. Whereas, as you mentioned, Trevor, with the Bedrock knowledge bases, it's literally just put everything in S3, click a button, and then you've got a GraphRAG application. So awesome. So once we have, so just walking through this code a little bit more. So we've specified where to look. Really, the creation of the GraphRAG is actually just going to come through this command here, which is we're just going to tell the system, our graph store, at least for our example, is going to be Neptune Analytics. Vector store is going to be Neptune Analytics. Now, do all the extraction from my documents and then build that graph. So this will take a couple minutes. And while that's running, I'm actually going to swap to my slides really quickly just to give you a more in-depth view of like what's happening behind the scenes.
Great. I'm glad you're doing that because I was just about to ask, like, what is this magical graph build doing behind the scenes? Yep. And to me, this feels kind of like the secret sauce, at least of the data prep, right? It also feels like a good way to kind of just understand a little bit better of the relationships that are being built here.
Yep, Absolutely. So the indexing that we just kicked off, what's happening behind the scenes right now is actually going to be a two-step process. So one is the extraction. So this is actually taking all your source documents and then doing what it needs to in order to figure out what actually goes in the graph. And then the second part of that is the actual build. So this would just be for all the nodes and edges that we've gathered from the extraction process, go put that in the graph. Similarly, for the vector side, all the vector embeddings that we generated from the extraction process, go put them in our vector store. So we're really going to focus on what's happening in the extract stage here, which you can see we've got a few different things happening. All right, so the first step of the extraction process, as we saw on the previous page, is chunking. So we're essentially going to take your source documents and then chunk them up based off of however you define. After we've got our chunk, we're actually going to do 2 LLM calls per chunk to figure out some more granularity of the information contained within each chunk. And so kind of the first call that we are going to do per chunk is we're going to do something called proposition extraction. And so propositions, you can kind of think of them as like general statements or a single sentence where you've got a noun and then, there's some relations between that noun and another noun, or an attribute is related to that noun somehow. And really the point of doing proposition extraction here is because we really want to try to clean up the content that is provided in a chunk so that we can get more granular in terms of the context that's going to be output from this. So just as an example, right, like I might have an input chunk that looks something like this on the left. So it's just a paragraph talking about this electronic diffuser product, and then it's talking about some features of it and then what it does. Now, what we're going to do is we want to be able to kind of clean up a lot of this context a bit better, because later on we're going to have the LLM do things like entity extraction, and it's going to be a lot easier for the LLM to accurately pick out entities if we can format from chunk to something that is a little bit more explicit. So for example, if we look at just this purple section right here on the left, right? Like as a person, when you're reading the paragraph, you know that, oh, it's the electronic diffuser that has this motion activated sensor. But out of context, it could be a little bit difficult to kind of tell, like it says with a motion activated sensor, but like what is the thing that has that motion activated sensor? And so proposition extraction is all about kind of like cleaning up the input chunks. So you can
It looks
see like how they
almost
map.
like the output is almost like allowing each one of those chunks to be like a standalone phrase, right? So that way, if that purple chunk was thrown into the LLM without the previous verbiage, the LLM could actually understand. Okay, this makes a lot of sense.
Yes. So this is going to be, we said there's 2 LLM calls per chunk. So the first LLM call is basically just doing this translation process of what we call proposition extraction. And then we're going to take those input propositions and then do what we call extraction of summarization. So you'll see here on the left, so for each of these propositions, we can then extract information about like what entities were mentioned in each of these statements, as well as the proposition itself would just be like that singular sentence. And then, because you can kind of see here, right, like from a singular sentence, it's a lot easier and a lot more clear to pick out what entities were mentioned within that. And does that entity relate to any other entities? Or does that entity have any attributes? So for example, here, if we just look at the blue one, the diffuser, it's not talking about any other entities in that sentence, which is why there's no entity to entity relationships extracted, but it has attributes. It delivers a call mean sent, and it has this nice feature of a button. So, And so now, once we've got this output, this is actually what forms the graph. So the output of the propositions is actually what forms the graph, but just to make it a little bit easier to visually parse, I just kept the propositions here. So you can kind of see how they start to map to our lexical graph, right? So we're really going to be modeling entities. So like the electronic diffuser itself would be an entity. That's going to be a node. We're going to start to pull what we call facts. So these are kind of like individual statements, right? So the blue one, right, we kind of have two facts because the diffuser delivers the calming scent and then it also has a feature of a button. So those are going to be pulled out into singular nodes, one for each fact. The overall statement is just going to be the proposition itself, which in the GraphRAG context, statement is actually going to be our key unit of context instead of the entire chunk, which a lot of traditional vector RAG strategies would use. And then topic, this was generated during the proposition extraction. So topic is kind of like just the general theme of whatever your statements are talking about.
Yeah. Melissa, really great job breaking this down for the audience. I do want to go back to proposition extraction. We have a great question. So, is the prompt in this step, proposition extraction, configurable or like to optimize for a specific search use case, for example, like scientific papers?
Yes. Yeah, so that is the nice thing about the GraphRAG toolkit is that a lot of parts are customizable, including the prompt. And just to give you an idea of what that prompt looks like, I have it copy and pasted in the notes here. So this is the prompt that we use. So this is just going to be the default prompt that's used for proposition extraction. One thing that you can modify is, well, I guess first off, everything is open source. So even if you wanted to modify some of the instructions or some of the prompting, you can absolutely do that. There are also some places within the prompts that you can easily just pass in a parameter and then we'll like pull that in and utilize that as part of the prompt. So for example, let me switch to a different prompt here, which is the extraction of like entities and topics and things like that. You'll see that we are Oh yeah, so right here at the bottom. So preferred entity classifications. For example, we provide a default list of classifications like product, sports team, company, location, so on and so forth. But if you wanted to provide your own list, you could just plug that in. And then similarly with like topics and things like that. So yeah, these are the base. You can definitely check out the base prompts that we use. And then there is a lot of flexibility to kind of add and modify to what would fit your use case the best.
Awesome. Thank you. Thanks for clarifying. And thanks everyone in the audience for asking such great questions. We really appreciate it.
Real quick before we move on, Melissa, by the way, if you are in the audience and you just popped into the stream and you're wondering, what are we talking about? We are showing you how to build your very first GraphRAG agent. And this is going to be up on YouTube as soon as in fact, you might even be able to rewind and go back to the beginning if you really want to start with us from the beginning. But exciting session where we're learning how to build our first GraphRAG agent. Back to you, Melissa.
Yes, absolutely. And I know we are kind of diving into some of the behind the scenes quite a bit here, but you really don't have to know all of this in order to get started, right? Because let me switch back to my notebook, which we should be finished with creating our graph. All you really need to know, honestly, to get started is you just need to have our snippet of code, which we'll put the link to in the description box. You just need to provide it your source documents, tell it to go build, and then everything that we talked about just now and more, it's going to go behind the scenes and do that for you.
Awesome. So it's like, here are the documents. Now go build with it.
Exactly. Yes.
That's awesome. Super easy.
Yes. Awesome. So I know we said in the title, you don't need any graph expertise here, and we don't need any graph queries, but I am going to run a couple graph queries just for the purposes of showing you all like what was actually built. Because we talked about the theory just now of what's going on behind the scenes, but what actually got built. And so I'm just going to run a couple cells here to set the visualization and the annotation options for the graph visuals. Just makes it a little bit easier to visually parse out. To generate graph visualizations in a Neptune notebook, it's really just a matter of writing a query that returns a path. So again, you absolutely don't need to write any graph queries in order to get your GraphRAG application going. Really just going to do this so that you can see what is in the graph that the toolkit made for us. And so here, as an example, I'm just going to be showing you the section of the graph for like the widget entity and then traverse all the way up back to the sources and the documents that we found in it. So let me expand this. So this is only looking at a very small slice of our graph, but we can start to see like based off of the colors. So the color coding by default for the notebooks is going to be color coding based off of the label. So that's why you'll see kind of distinct layers of colors. They kind of align with the theory graph that we were showing on our slides, where you've got your entity node, which is here, which is going to be our widget. And then you've also got your facts, your statements, and then your topic, and then your chunk, and then the actual source document that it came from. All right, so this is just showing for one entity, which is that widget that we care a lot about for our problem statement. And then you can see, how it relates back to all these facts and all this information that we extracted from our source documents.
Very cool. This is the graph charts are maybe my favorite part of these streams. It's way more interesting than showing people like a SQL response or something like that. And by every time you show these graph, it just becomes more clear to me why this is important for AI applications. It just the visual makes it clear to understand that, for me anyway, to comprehend kind of why you might miss some of these complex relationships if you're just kind of doing the typical semantic similarity. So it makes sense that GraphRAG is catching on in this space.
Yeah, Trevor, I totally agree. I feel like the visual, like especially if you're a visual learner, just helps so much. And yeah, I think it's so cool. So thanks for the demo, Melissa. I feel like I'm learning so much from you right now.
Yeah, and sorry, the last visual that I want to show really quickly before we start to ask questions and then do the agentic part is I just want to show like a small subgraph of, we saw the widget on that previous view. So like, okay, widgets mentioned in like this statement is about this topic, came from this chunk and source, so on and so forth. But really what the graph structure that is really going to help with helping you find this relevant yet dissimilar information actually is going to be through like entity to entity connections, right? Like we can easily see, and it makes sense how an entity is mentioned in a document, but what we really care about and what's really going to help us find additional relevant yet dissimilar information is how certain entities mentioned in a question relate to other entities. And so just to show you an example, this is just a small subset of the entity to entity graph, but you can see here that as part of the graph that is extracted and built as part of the toolkit process, we are, in addition to doing entity extraction, we're also connecting entities back to other entities based off of
this is so powerful, right? Because I'm looking at this like that line that says believes about, that was like a light bulb moment for me, because now we're talking like this relationship mapping takes us beyond a use case of just kind of querying data, and now this is more of like, seems like something that can be used for personalization. If you can map an individual's history or thoughts on a subject to the actual subject of the query. So this clearly will kind of opens up some personalization paths that I can't imagine being capable kind of just relying on the typical LLM context.
Yep, absolutely. And this is kind of the core of what makes GraphRAG magic almost. It's like utilizing the entity to entity relationships to find that extra information that is not necessarily semantically similar, right? Like widget in Taiwan, widget and Samantha Watkins not semantically similar, but they're directly related in some way. So you want to see, like, is that extra information connected to my key entities that might be relevant to answering the question completely.
Amazing. Super, super insightful. Excited to kind of see what happens when we strap some agentic framework on top of this data. Because like I've got I'm just kind of wondering, like it's clear to me as a human how I can reason over these connections, but I just want to know how the LLM is,
Yes.
how it ingests all this and figures it out.
Yeah, absolutely. So that's where querying comes into play. So really, we mentioned earlier, all you need is a little bit of Python knowledge and some data sources to get your GraphRAG going. This is the other little bit of Python that you'll need to know in order to actually get some answers out of your GraphRAG. And it's really just a matter of, after building your graph and vector store, which we did earlier, pointing back to them here, ask a question. So we're going to ask that same question that we always like to ask. So what are the sales prospects for Example Corp in the UK? We won't get too deep into the retrieval process and how that works in today's session. But essentially what it is using on the back end, it is using a combination of vector search to find similar information, and then also using graph search to find relevant yet dissimilar information to kind of combine possible results, re-rank them based off of relevance, and then use that to kind of pick out what is the most key context that we need in order to pass back to the LLM and get an answer. So this is the response that we got back, and skimming through it, it says looks promising, but I think they might be facing significant challenges due to supply chain issues. And so that's kind of that nuance that we're getting pulled out of the graph because of those extra entity to entity relationships that we have stored.
Yeah. And this response, if I understand, this is we're now beyond the raw response, and this is actually like taking the query, throwing it into the LLM, and then this is the LLM having reasoned over the response that you got.
Yep, absolutely. Okay. And one thing that you can check out as well, if you are interested, is as part of the response that's generated, we can actually see the individual topics and statements that are passed in as context to the LLM. So traditional vector RAG tends to use chunks as the context, so pass in some most relevant chunks. Here for the GraphRAG toolkit, the unit of context, our unit of context is actually not the chunk, but it is the statement. So it's going to be those granular kind of sentences that's like X says something about Y. And you can actually inspect the final response to see what actually got passed in. So some of the topics and statements that got passed in as context to the LLM would be, for example, this. So the any company logistics topic, and then all the statements, the individual statements are the ones that'll get passed in. So not everything we see on the output here, but just individual topics and statements is what is actually getting passed in to the LLM to generate our final answer.
Amazing. Makes perfect sense to me. Thanks for walking us through those queries. I think now I'm really interested to see kind of like, just like what it looks like when we plug that into an agent or something. But folks who just tuned in, just so you know, you are in the right place if you want to learn how to build your first GraphRAG powered agent. So far, we covered the kind of basics behind GraphRAG. We actually showed you how to build the relationship mapping with our graph toolkit, and we just wrapped up kind of showing you how the LLM can reason over all these interconnected relationships between data. And I think, if I'm not mistaken, Melissa, we're approaching the big finale of plugging this into some agent, so folks can kind of get a sense for how you might expose the backend that we just built to users.
Yep, absolutely. So we're in the same notebook. This is also at the end of the example notebook that we'll be providing in the link as well. So you'll have all the resources from today in one place, provided in the link in the description. So as Trevor mentioned, we've got our GraphRAG. Now we want to actually expose it to our agent and use it as part of kind of like a greater agentic flow. And so the way that we'll be doing this today is we're really just going to create an MCP server. And that server is going to expose our GraphRAG to agents as a tool. And so it's just a few lines of code here to get that set up. One thing that you can do as well, so for our example here, we only have our one graph that's talking about example corp. So our one MCP server is just going to expose one tool to our agent, which is going to be a tool that lets the agent ask questions about, example corp and then any company. If you have a situation where maybe you have multiple distinct corpuses of information, what you can do actually is expose one tool per kind of like distinct graph for your GraphRAG. So you might have, for example, a repository of information about example corp, which is what we have here. Maybe you have a different repo that talks all about like products and product features in detail, and that might be a separate repository. You can actually expose those as individual tools from within the same MCP server. Here we only have the one, so it's pretty straightforward. As part of the server generation, what we're going to do is we're actually going to have the LLM generate the tool summaries for us. So it'll just give us a general description of like what kind of data is in my GraphRAG, what kind of questions, sample questions can I ask of this? And that just helps the agent figure out if you've got multiple tools pointing to individual graphs. Like which one should I pick in order to answer the questions that I want answered? All right, so I'm going to just start the MCP server here and then also create an MCP client that our agent will be able to use. And then just to show you an example of the description of the tool, which is going to be a description of our graph, this is what our LLM came up with. So all this information is going to be used by the agent to help it figure out like which of these graphs should I use in order to help me answer my question. So we only have the one graph at the moment, but if you had multiple, it would just show up like the name of the graph, or the tenancy is the term we use within the toolkit. And then just a description of generally what is in the graph, as well as you can see some example questions that it might be able to ask.
Awesome. Melissa, and we also just have one question I want to bring up quickly from the chat. How often are GraphRAG agents built alongside MCPs?
So I would say that I feel like they kind of make sense to go hand in hand together, right? Because I can imagine that you might have maybe other graphs that are not necessarily GraphRAG specific that can still answer relevant questions from an agentic framework. So for example, if we're talking about, let's say, like the fraud domain, I might have a GraphRAG application that is looking over like those financial compliance reports and things like that. And then I might have another graph that is actual like instances of fraud data. So kind of one common use case we see for fraud and graphs outside of GraphRAG is kind of modeling accounts, users, and then shared attributes like social security number, emails, phone numbers, addresses, things like that as individual nodes. So you could have an agentic flow that is maybe it's like a fraud investigator helper, and you want to ask the agent, can you show me how account 123 might be involved with account 456 in some fraud ring, right? So the agent is going to go back and it sees it's got a tool for the GraphRAG with the financial compliance reports as exposed as a tool. It also sees it has a more generic tool that's actually just going to query that instance data in our fraud graph. And then it can go and actually check out like, oh, you're talking about account 123 and account 456, which are specific instances of fraud in your fraud data set. So I'm going to go pick this tool that's going to let me generate a path and then a graph visualization of how your instance data is showing that graph pattern, that fraud graph pattern. And maybe after that, you can see the fraud graph pattern and you kind of see what's going on in that generated graph visualization. And then from there, maybe the fraud investigator is then going to ask its helper agent, how are these accounts violating like some compliance report? And then from there, right, your agent can then kind of go and then pick out the tool that's going to be more tied to that GraphRAG flow. So I think in terms of agentic flows plus GraphRAG, I think it makes sense together, but depending on what other tools and use cases that you plan on exposing to the agent, that'll kind of drive whether or not you'll build them together. So
Gotcha. So it depends.
yeah.
Nice, nice.
Yeah.
So with that, let's move on. I know we have like a little bit less than 10 minutes. So let's get to the grand finale of this demo. I'm so excited. So I'll let you take it away.
Yes. So the last part is really pretty straightforward. It's really just creating that agent and then asking a question. And so here we are using the Strands SDK to build our agent, and we provide it just the generic prompt to use. And then of course we're passing in our question, our standard question about the sales prospects for Example Corp in the UK. So let's see. So it says it looks pretty positive. It's saying such great things here. And then again, at the end, we can see that it's mentioning like warning you logistical advantages and challenges. So it seems like it would be promising and strong, but just watch out for the supply chain disruption. So we can see that from a GraphRAG application, right? When we directly queried it, we saw kind of the nuanced answer. Now we just put that GraphRAG application behind an agent, and then we also see kind of that same nuance. So. Awesome. So that is all I had for this this demo. Again, the link to this notebook and then all of the sample data sets that you need, they're all going to be linked in the description. If you're interested, one thing that you could easily do is actually swap out the data sources that we use here. So plug in your own data sources, scrape a few web pages off a website to try it out, and then you can kind of see how the structure of the graph changes based off of the data that you feed it.
You know what's incredible is that we are 54 minutes into this live stream, and if you stuck with us the whole time, you have successfully learned, or at least have all the resources in the replay of this video to know how to build your very first GraphRAG powered agent. The reason that's so exciting is because I kind of thought that to learn GraphRAG, I would have to go back to college and get a PhD and become a super mega big brain scientist. But it turns out just a little bit of Python code and like a basic corpus of documents. It looks like just about all, maybe access to AWS and Neptune, if you're lucky, is just about all you need. So
Yeah.
very cool, Melissa. Thanks for taking us through that.
Yeah. Thanks, Melissa. Thanks for letting us know we don't have to go back to college for this. Yeah, this is awesome. And also, it's not like it takes like even 6 months to build something like this. Like you saw today, it was so quick. We did it with under an hour. So I think that's awesome.
Yeah.
Amazing. I mean, we have a couple minutes left. I mean, I think with the time we have, maybe we could just pop through a couple of those lingering questions that we didn't get to in the chat, and then we'll send folks around the week. But before we go to the questions, just as a reminder, we're doing another session on GraphRAG and how you can leverage it in AI tomorrow. Check us out. We're going to be on YouTube, LinkedIn, and Twitch, depending on what your preferred platform is. And we're actually going to be walking you through kind of 3 really key use cases where GraphRAG is of use, from cybersecurity to fraud and financial crime investigation and detection to I think even account management, which I'm kind of excited about since that's what I do in my day job. But any questions that we haven't covered yet that we could pop through in the last couple of minutes here, Emily?
Yeah, let me look. So let's pull up. I think we pulled up the same one.
Oh, amazing. Cool. Yeah. Great minds.
I pulled it down and I was like, oops.
I want to know the answer to this one because like all of my customers use Postgres. I work in financial services. It's kind of like the database of financial services. And I guess what are the back ends that can support something like this, Melissa?
Yeah, so for the GraphRAG toolkit, to use it, you basically need something to store your graph and something to store your vectors. And so at the moment, the Postgres support is only for the vector store. So we'd only be using it to put the vectors. You would still need to have a graph store like Neptune Database, Neptune Analytics, or Neo4j to actually store the graph structure. So yeah, the graph isn't mapped onto Postgres. It's just Postgres support would only be for storing the vectors.
Hey, and by the way, if you're on the hunt for a great Postgres database, I hear that Amazon Aurora is not half bad. It's what a lot of my customers use, and it's not a bad place to run your Postgres databases. Did we cover this question about MCPs yet?
I think we might have.
Well, shoot. Well, Isaiah, my buddy, asked that question, so I wanted to at least give Isaiah a shout out for asking us about MCPs. I'm a big MCP fan. Although it's funny how fast MCP went from being like the hottest thing to kind of just like another commodity way to plug APIs into agents. We've got a couple minutes left. I guess I always like to put. I hate to put you on the spot as always, Melissa, but any final words of wisdom, call to action for the folks that have been hanging out with us for the past hour?
Yes, I would say if you think you might have a use case for GraphRAG, really just try it out. It's super easy to get started. You can either use Bedrock knowledge bases, GraphRAG, if you want the least amount of lift, like literally just put stuff in S3 and then tell it where to look, and then you've got a GraphRAG application up and running. Or as you saw today, our example, it's really just actually like 2 small snippets of Python code that's needed to get started with the toolkit. So put your data somewhere, tell the toolkit where to look, and then kick off the extract and build process. And then once that's done, you're ready to query. So super easy to get started. Couple different ways to do it. And yeah.
Amazing. Well, thank you so much for spending the hour to sharing all of this great knowledge with the Builder community. Folks, as a reminder, we run this show at the same time every Thursday. And then tomorrow, we have a special event where we're going to double click on some of the key use cases for GraphRAG in the industry right now. So thank you all for tagging along. Thanks for our production team for helping shepherd us on today's show. And we will see you all tomorrow. All right. Bye, everybody.
Bye,
Yep,
everyone.
thank you.